Okay, so let me start sharing the screen also. Okay, I hope my screen is visible now. People are joining. Just 2 more minutes will take and we'll start the session. I guess people have seen your second eye marks also, everybody. Yeah. There may be one more eye for you people. Not for all, but for few who have missed something, I guess. But you will get notification for that. Like for third, fifth semester, your compensatory eyes on 17th, something, I guess. The dates are specified it. 17th, 18th, and 19th, I guess. You have your compensatory internal schedule only for the people who have either missed or who have any medical emergency and something like that. Okay, so yeah. Meanwhile, it's started and 13 people are there. We'll start it. I'm not ready for it. Shall we wait for another 2 more minutes? If people join. It's a weekend now. We are about to enter the weekend. Okay. Okay. Meanwhile, people join. I'll just try to do a revision of this. Okay. So we started the unit 5, which is IPC, which is called as inter-process communication, right? So meanwhile, we studied everything about Unix now. What is the introduction of Unix? What are the different types of files available in Unix? The Unix APIs, the Unix process, the signals, and now we are into, once we know everything now, then we'll talk about process communication, that is inter-process communication. In the previous class we just discussed about what I mean by inter-process. When one process wants to communicate with other process, we call it as an inter-process communication. In this unit, we'll study about which all the APIs, system calls are available with which one process can communicate with other process, maybe on the same system or maybe on a different system. Okay, so that is what about this chapter is all about, inter-process communication. We just discussed it. Then the things what we'll be covering in this unit or this chapter is introduction, what is IPC, what I mean by pipes. There are functions P open, P close. There is something known as co-process, FIFOs, message queues, semaphore, and shared memory. So FIFOs and all, I guess you have just seen. We worked with the file locking, right? There we have studied about all these APIs. These are something new to you people, which we'll be taking later on. Okay. So here we studied about what inter-process communication does. It allows us to control one application and for several applications to share the same data without interfering with one another. Just like a client-server communication, you can say, just like a broadcast message, it enables one application to control another application. So what happens here is, since for example, if you are part of n number of groups over there, there will be an admin who will control it. The minute he posts something, it will be for everyone available there. So what is happening? One person is communicating with different person. That is, communication is happening. So same thing happens with Unix also, inter-process communication. Now, this IPC is required by multi-processing systems. That means which does more than one type of processing. It is not supported only on a single process operating system. See, there's only one process running. How can you enable inter-process communication? Because there will be only one process running. So please remember, IPC, that is inter-process communication, is only helpful for multi-process systems. So in this regard, Unix has provided many IPCs. There are already ready-made available IPCs are available in Unix. Which are those? There are something known as half duplex pipes, full duplex pipes, FIFOs, named full duplex pipes, message queues, shared memory, semaphore, sockets, and stream. So all this are nothing but the various means by which we can communicate with other processes. So this was all about the introduction part. Then the very first, pipes. So pipes are what? Pipes are nothing but the oldest form of IPCs. So pipes are used when two process sorry, when two process wants to communicate with each other. But the drawback of pipe is it data flows only in one direction. Just like the normal pipes, water tap pipes we have, right? So water flows only in one direction, right? It can't go in two directions. Same way, pipes also are here. So pipes can be used between the processes of common ancestors. This is also one of the drawback. That means when you wrote a program, so in the program there is a parent process running. So in parent you create a child. We know how to create a child by the system called fork. So pipes, the two drawbacks of pipes are it is half duplex. That is data flows only in one direction. So if you want the process to communicate some other message, then you should use one more pipe, second pipe. If it wants third message, it will use third pipe, and so on. The number of pipes keeps on increasing. This was the first drawback. Second is it is used only between the common ancestors, that is within a process itself, between a parent and child. You can't have process 1 dot C somewhere and process B dot C somewhere. You can't use pipes. Pipes are used only between the common ancestors, that is usually a parent and child process. Okay. So this is what we studied in the previous. So how they support with a system called pipe, which has one argument, which is a file descriptor, which has two parameters in it. Because whenever you see a pipe, usually the normal pipes also, whatever we use, it has two ends, right? Again, I'll go back here. I'm bad at drawing, but I can just try to figure it out something. This, the size I'll take like this. Okay. We don't know what is a pipe here. See, if this is a pipe, something like this. So pipe has two directions. In one direction, the water flows. In the other direction, the water comes out. Right. This is a normal water pipe, I can say. Right. So same thing. What happens in Unix also, just like a pipe. This is used for communication. Now this is there is a plus one, and there is a process two. Two process are running. Usually, I now call it as a parent and child process. When parent wants to communicate with a child, it may not always happen that both are of the same this. Now I can say here again, it comes here. Okay. Both are not of the same sync. That is, child and parent are active at the same time. So parent wants to communicate, child may not be active. So that time what happens? Parent has to save the information. There is a medium. See, I may be talking in a rapport which few people will understand, few people will not understand. Right? The same rapport. Some people may grasp or may say 20 words in 1 minute. Some people may talk 30 words in 1 minute, and so on. So the way with I'm pushing the data is not the same way in what you are understanding the data. So there should be a medium through which you can communicate, so that later on down the lane also I can see the information. So when parent wants to send the information to the child, they can't communicate directly because not all processes are active all time. So that time they require a storage with which they can communicate. That means rather than communicating directly, they send the message somewhere here, and from here the parent information goes to the child. So what is this? Now this is nothing but the IPC, which helps to communicate two processes. And the first one what we are studying is a pipe. Okay, the first one what we are studying is a pipe. So that is what we started in the previous class. So pipe has two ends. Usually what I said, the same thing. This is when I say a pipe here like this, if I draw, pipe has two ends. So this is the first end of the pipe and this is the other end of the pipe. And it is half duplex. That means water also in the pipe flows in one direction. If it's this is the inlet point, this is the outlet point. Same thing happens. If this is the inlet, this might be the outlet. So data flows only in one direction. If parent wants to send information to the child, it is this. If there is one to another process, you can use another pipe over there. So a pipe has two file descriptors here. So it always returns 0 if okay, and zero on error. Sorry, okay. Correct exit and one on error. So the two file descriptors what we have used is nothing but for the reading and writing purpose. So if a parent wants to commit with a child, it has its own pipe. So it has to write to the pipe from one end, which is called as the reading end, and it will read. The child will read from the other end. Sorry, parent will write to the pipe from the writing end, and child will read from the pipe from the reading end, right? So the file descriptor here also has two values. FD0 indicates opening the file for reading, and FD1 indicates for writing. That is what we said in the previous class. Now this diagram will clear your doubts here. See. So there is a pipe here, user processor name. It has always two ends, FD0 and FD1. So when a user wants to communicate, it will communicate through a pipe, because that was it says. The two ways of picture of half duplex pipes are shown here. Left half on the figure shows pipe connected to a single process, and the right half shows that the data of the pipe flows through the kernel. So usually it goes through the kernel itself here. So FD0 for reading purpose, FD1 for writing. That means we studied in the previous class. Why I am emphasizing again, because it is very important here. So whenever you want to write anything, you write on the pipe from the writing end, and whenever you want to read it, you read from the reading end. So this shows you here. So a pipe on a single process is next to useless only, as I said, right? When a pipe will come into picture, when there is a parent and child process. See, now this is a parent process. Let's make it a slideshow. And this is a parent process. This is the child process. So every process pipe has two file descriptors, one for reading end, another for writing end. So reading end is this, writing end is this, up to us. So reading end is always indicated by FD0, writing end by FD1. When parent wants to communicate with the child, first it has to fork a child process. Then what does the parent do? Parent will, see, this is from parent to child I'm talking here. When parent wants to send information to the child, what does parent do? Parent writes in the pipe from its right end, and child reads the information from its read end from the pipe. So FD0 is for reading. Similarly, when child wants to write, child writes to the pipe from its right end, and parent reads from its read end. So at any time, since I said it's a half duplex, either of the connection should be open. Either this should be open or this should be open. So when parent is writing to the child, parent writes with its right hand. So it should open FD1, but at the same time it should close FD0. On the other hand, child should open FD0 because it is reading, and should close FD1 because it is not writing. If I say the vice versa, if child wants to send information to the parent, then it should write to the pipe from its writing end. At the same time, its reading end should be closed. And here, parent reading end should be open and writing end should be closed. That is what I told you yesterday. See, this is how it goes. We studied. We studied all this also. So this was the program which we discussed at last class also, but again let it be a revision. Show the code of to create a pipe between a parent and its child. Please remember, parent and child. If you get something like this in the exam also, draw this diagram at the other end, somewhere at the rough line. You'll understand which one to open and which one to close. Now see, from parent to child it is. So what happens? I've just created a pipe here. Okay, I call the system called pipe. If it is less than 0, error. If not, it will execute. So PID equal to 4. So pipe is created here. File descriptors are 2. Yes, true. So PID equal to fork. Now child is created. Okay. If less than 0, it shows an error. If it is more than 0, a child is created. Now parent and child. We know now. If fork value is, if this writes greater than 0, it is in parent process. So we are writing from parent to child. So what I'll do is, if PID is greater than 0, that means you are in the parent process. Now parent is writing to the child. Parent is writing to the child. So its reading edge should be closed, which we have done it. FD0. See, look at this. I have created a pipe. Its reading edge is closed. Then I'm writing to the writing end. That is FD1. I'm just passing a message hello world, which will be passing to the child process. So this is what I do in parent. And else, if the PID is equal to 0, that will be in the child process. Now child what is doing? It is reading from the pipe which parent has written. Which will read from which end? Its reading end. So it's not writing now. So at that time, the child closes its writing end and it reads from its reading end from the pipe to which parent has written and display the message on the standard output. This is when a parent sends a message to its child. Now again, please see I have bolded here also, please make a note. Between a child and a parent. Now the next scenario is when a child wants to send its information to the parent, some information. Again the same piece of code here. Now see, else if PID is equal to 0. That means you are in the child process. Now child is sending to the parent. What happens here now? Child should close its reading end because child is sending. So child is writing. So it should open its writing end. So this is FD1. So this is what you people should not make a mistake. It closes its reading end and it writes, open its writing end. So it writes to the pipe. Now parent. Now what does parent should do? Parent should close its reading end, writing end, because parent is reading from the child. So its write end should be closed. At the same time, its read end should be open. Yeah? This is what we said in the previous class till here. So I said also in the exam they can ask you what is pipes, explain the limitation and a sample program. Either parent to child or child to parent. Okay. So only I just again wrote it and I just came back here. Usually it is for 10 marks, where syntax limitations will take you for 5 marks and the program will take you for 5 marks. So I don't want you people to lose 10 marks if you get something like this in the exams also. Okay. I hope this is clear now, everyone. Yeah, the people who missed in the previous class also, please make sure that this is clear. This concept is very clear. Okay. Now the next concept, what we'll say, this was for pipes. Now there is something known as P open and P close. Now why the system calls are used? We have seen now in pipes what did we do? We created a pipe by the system called pipe. We wrote to the pipe. We closed the pipes. We fork a child process. All this we did using pipes, right? So with the pipes, what we did, we first created a pipe by the system called pipe. Then we created a fork. Then again we close the unused end. If you're writing, read end should be closed. If you're reading, write end should be closed. All this we did, right? All this we did. So these are the drawbacks what we do when we are working only with the pipes. So to overcome these drawbacks, that is, why should I every time create a pipe? Why should I every time fork a child? Why should always I should close the unused end? That is close FD0 or open FD1, whatever it is. Why should I do that? To overcome all these drawbacks, Unix came with a system called known as P open and P close. So it is a common operation which is used to create a pipe to another process, to either read it from its output or send its input. The only difference here is P open and P close will not do all this work. It will not create a pipe, it will not fork a child and not close the unused end. So to avoid this, Unix has come up with the functions known as P open and P close. So what does P open and P close have? So this is a file pointer. P open has two arguments. The first one is the command string. Now command string is nothing but the command which you want to execute. The command which you want to execute is nothing but the command string. There is a sample program after this slide which you will understand. This is a command string which tells you which command to execute, and this is a type over there which can be either R or W, which I'll tell you in the next image graphics. We'll understand that. So this returns file pointer if okay or null on error, and P closes, it terminates the status of the command string. So whatever the command string you have passed, it closes the termination status. So how this works? It works this way. See here now. The function. Now when I'm talking about child to parent, look at the arrow notations also. The function P open automatically does a fork and executes exe to execute the command string. So you don't have to explicitly say anything. So the function P open will, when you call the P open, it is assumed that it does a fork, and exec, that is execute, to execute the command string. So whatever the command string you have passed, it gets executed and returned a standard IO file pointer. Now the next, which was I said about the type here. Okay, so this type, if the type is R, then the file pointer is connected to the standard output of the command string. See, what it does, it creates and passes through a pipe to either of them, either to the standard input or it passes to the standard output of the parent. So see here, since if the second argument is R, that means that the file pointer is connected to the standard output of the command string. This is the file pointer, it's connected to the standard output of the command string, which is at the child process. Please don't get confused here. See, this arrow, don't get confused here. Now from parent, you're executing this command string. Now, since I have passed R, it is connected to the standard output of this command string, which is at the child. And if it is W, then the file pointer is connected to the standard input of the command string. Look at the arrow notation, okay? Please don't get confused. In P open, P close, see what happened, what we did in pipes is, we called pipe, we did a fork, we opened the used, whichever the used ends we want, we close the unused end, all this we did. So here we don't do anything. P open will automatically, whenever I call, it automatically executes this command string. Command string is nothing but it calls fork and executes. And W indicates it is connected to the standard input of this command string. So which is the standard input, to that it is connected. If it is W, and if it is R, it is connected to the standard output of the command string. Okay, this program will help you to understand. Now what I'm doing here is I'm executing ls all options. I want to execute ls all options at the child. So what I'll do is I'll call p open here. Now what does p open do? It will fork and execute in a child process. So parent process has called p open. That means it automatically has called a child process, and it will execute this command string, which is ls star, all the options of ls, long listing of files. Now it is on read. Now it is read, it passes to the standard output, maybe the output screen which I am having. Or standard input may be a input file or a text file. So since that is passing to the standard output, it opens this, and this is fgets. Now fgets will get the information from the file pointer, the path max, whatever is the max size, and displays it on the output screen. Printer, the whatever is the string output I have got, display it on the standard output. So what did it do now? Now parent is communicating with the child process through p open system call. It is passing the output of ls star, that is ls all options, to the child, and is displaying the same message on the output screen. So this is a sample snippet of code which tells you about how a p open will create a child process, forks a child, executes this command, and the type is R. That means this is R. What does it do? The file pointer is connected to the standard output of the command string. Now the command string, whichever is the standard output, for that it is connected. So this is what p open and p close does. If it is asked in the exams also, you should tell what is the need of p open and p close, because pipe does all this, creating a pipe, forking a child and all. So to avoid this, p open and p close are used. So tell me the syntax of p open and p close. How exactly what happens with the type? If it is read, it is connected to the standard output. If it is write, it is connected to the standard input. And a sample code. If you Google it, if you see the textbook also, there's a bigger code for that. But this is a simple code which you can understand also, and you can take home also. Okay. So this is all about p open and p close. The drawbacks of pipes are taken care by p open and p close. Okay. The next, which is nothing but a co-processes. Now, what is a co-processes? So to understand co-process, first you should understand what is a filter. So in Unix, a filter is a program which reads its input from the standard input and writes its output to the standard output. Now this is what actually a filter in Unix is. So what is a filter? A filter is a program which reads its input from the standard input and writes its output to the standard output. Please don't get confused. A filter is a program that reads its input from the standard input and writes its output to the standard output. Now standard input may be a keyboard for me and standard output may be a monitor for me. So filter in Unix is a program. So whichever is the program reads the input from the standard input and writes it to the standard output becomes a filter for me. Now, a filter becomes a co-process. Please, filter becomes a co-process and the same program generates the filter input and reads the filter output. I repeat it, a filter becomes a co-process when the same program generates its input and reads its output. The same program, if it generates its own input and it reads its own output, then we call such process as a co-process. Now, what are co-process? Co-process normally runs in the background. See, for example, just like what I can say, a notepad. See, you're typing it and the same time you're seeing on the screen also. Now, notepad becomes a co-process. Yeah, same time you're typing, it reads the filter input and it generates the filter input and reads the filter output. Now, whatever input you're typing from the keyboard is seen on the screen and you can read it also. So the notepad can say it as a co-process. Now, what are the co-processes in Unix here now? They are the processes which runs in the background and its standard input and standard output are connected to another program using a pipe. Now, this is a big terminology to be explained, but understanding a snippet, co-processes are nothing but the programs which run in the background for you. That means input of one is passed as an output of two other. Such processes we call it as a co-processes. What does the co-process do? Co-process creates two pipes. One is standard input of the co-process, another is the standard output of the co-process. Please remember that. So when your co-processes are there, it always creates two pipes because one process in the background is monitoring your activity and the other process is giving the detailed information about your activity. You see, one process, take a simple example of a mobile phone. In mobile phones, you use so many apps, right? So what happens, there is one process which is running in the backend, which is monitoring what you are doing. Yeah. Now, once it gathers all your information, it passes to another process. Now, from that, you can just check it out. It monitors how much is your data usage and all everything. So when you open the other, it will show you data usages for today. For example, if you're a Geo user, on the top you can see data use for today is out of 2 GB, 1.5 GB, something like that. Now this is one core process which is taking the input from your mobile, reading all your data. And when you see the detail in the system summary, you will see this 1.5 GB data, how it was used. Maybe 500 MB for Instagram, 200 MB for WhatsApp, something like 800 MB for your Google Class, which is going on, and all that. So what is happening? There is one process which is reading all your information, and the same information is being passed to other program. Now it is running at the back end. See, please understand this practically. On the top end of the mobile, it will always shows you memory data use is 1 GB, 1.5 GB, or something like that. That is one co-process which is reading your input, and the same is passed to the system information where you'll get detailed. Like out of this 1.5 GB, 500 MB was used for this, 500 MB used for this, 500 MB used for this, something like that. So the co-process always creates two pipes. One is the standard input of the co-process, another is the standard output of the co-process. That means it shares information from one process to another process. Now this was all about co-process. In the exams also, they won't ask anything more about co-processes. They can only ask what is the definition and need of co-process. Okay, I hope this is clear now. Any doubts in co-process? I'll come back here. Anybody has any doubts in the co-process? The best example is your mobile phones. It is reading the data and it is excluding the data also, passing the data to the other end. This is all about co-processes. No doubts here, right? If at least yes, no in the chat box for me, anybody? Anybody in the chat box for me, please? Understood this? Yes. Okay. Thank you. Okay. Now we'll go to the next concept. So this is all about co-process. Okay. Now look at this, how this co-process works. There is a parent and child. That is what I'm talking. Driving a code by writing its standard input and reading its standard output. So from pipe 1, we know now FD1 is for writing, FD0 is for reading. So I'm writing it to standard input, and parent is writing to the standard input of the child, and parent is reading from the standard output of the child only. That means it is sending its information to the child. Child does the processing, displays its output in its own window, and parent gets its output again. Are you understanding what I mean to say here? For example, if any task is given, okay, I will give a simple example of this. I'll give some task for you people. Please complete this work at the same time. So what you do, you forward this message to your friend. So what your friend does, he does the processing, he gets the output, he shares the screen with you. What you do, you take the same and you forward it to me. Getting it? So what is happening here? What is your task? You're sending the information to the child, standard input for processing. Child processes it and you're reading it from the child output window. So within the same process, it reads from the standard input and writes on to its standard output. This is how your co-process works. Now next is FIFOs. So this was all about initially about co-process, P open and P close. But we only know now what happens in P open and P closes. They are only used for related processes, right? Pipe, P open, P close, or co-processes. These are used only for related processes, that is parent and child. So the disadvantage of pipes, that is, what is the disadvantage of pipe now? Pipes can be used closed only in one direction, fine, it is half duplex as I said. The other disadvantage is it is used only between the related processes. So to overcome the drawback of this, Unix has come up with the next API called as FIFO. Now what is this FIFO? FIFO can be used to communicate between unrelated processes. Please make a note of it now. FIFOs can be used to exchange information between unrelated processes. It should not always be a parent-child process. It can be a two different processes also. So, which we did in the term work. We had worked on the term work, right? FIFOs, the inter-process communication, the term work number 4, I guess. Yeah. So there is a parent process, there is a child process, right? So parent is sending from parent to child. Both are different programs. You're running on two different terminals. So they're unrelated. Parent is not related to the child, right? So that time we use FIFOs, the third term work which we did. Okay. So again, this is just a brush up of that. FIFOs are called nothing but we know now. First in, first out. So they are used to overcome the drawback of pipes. That is, pipes are used only for related processes. So FIFOs can be used for unrelated processes also. The syntax of FIFO is MK FIFO. The first is nothing but the path name. The second argument is the mode. So path name is nothing but the name of the FIFO which you are creating, and mode is nothing but the permissions of the file similar to the open API. In which mode, read mode or write mode you are using. Okay. So FIFOs are usually used by shell command to pass data from one shell file to another without creating a temporary file. What happens here in FIFO now? You just pass the information to a FIFO. From one end you keep on passing it, from the other end the people keep on reading the information. So where FIFOs are used now, moreover, FIFOs are usually used in client server application to pass the data between the client and server. Please make a note of it now. It is used between client server. Because what happens? See, if I want to broadcast a message to you, I'll not send a message to you individually. Yes. Right? And I'll not wait for whether we are active or we are online or not online. What I'll do is I'll send only one message in the WhatsApp group. What I'm now here from my end, I'm a server. And you people are the client end. So people, I'm passing this information in one group, and the people who are access part of that group will read the information. Right? See the FIFO. So this is usually used in client server communication. Also, using FIFOs to duplicate the output stream. So FIFO is not only used to pass the information, but also used to duplicate onto the output stream. I should be very clear. You know now, MK FIFO is used to make a FIFO. You know what is this now? This is a T command is what? This is pipe. This is a pipe. So what does this do? You have said, I guess, the pipe notation. T is a command in Unix and shell which says that pipe is nothing but output of one, now if I say this is the pipe, output of one is passed as an input to another, the pipe. Please remember, what does pipe works in a shell? Output of one command is passed as an input to another command. Okay, this is a pipe. But there is a T command. What is a T command? It will say that not only pass the output of one command as an input to other, but also, at the same time display the output of one on the output screen. That means you are diverting it. Output of in file is as passed as an output input to FIFO1, but at the same time it is displayed on the output screen also. So T command, what does the T command do? It takes the output of one command and passes as an input to another command, as well as it displays it on the standard output. So this is how exactly it works. See now here, there is an input file, there is a program. Now this can be sent as an output to program 3 and program 2. Again, if I use the same thing with the T command, what happens? T is, this will not only send to program 2, but also you can use a FIFO and program. That means it will pass to the output screen also and also to the program 3. This is what a T command does. Please remember, T command takes the output of one command and not only passes as the input to other command, but it can be passed onto the standard output also or some other file also. Now here in our case, we are using it for FIFO. See, input file program 1, I can pass it as an output to program 2 as well as program 3. But here what I have done is, since I have used a T command, T will not only send to the other command, but also you can pass to an intermediate device also. Now here we, as I said, you can pass it to standard output or you can pass it to the FIFO file. Okay. Very important students. I'll just take another 5-10 minutes for you because this is usually asked in the exams. If you see previous question for all time, 10 marks sure question is this only. Explain client server communication using FIFOs. So what exactly it happens here? Okay, not more than 5-10 minutes I'll take. Okay, what happens here? Now forget about this. First look at this point. So since I'm talking about a client server communication, you know, there is only one common, take an example now. We'll take a simple example now. We have n number of service providers. We know now customer number is a common number, right? A common number. So assume that this is one client, this is another client. What will you do if you have problem with your Geo connection or Airtel connection? What will you do? You send a message to the service provider, right? Please pay attention. Okay, just a minute. Let me see how many people. At least 22 people. Please pay attention over here. Okay, I just want you to get this without studying later on also. So look at this. Assume that these are the two people who are using a Geo connection or Airtel connection. You have some problem with your data connectivity, so you send a message to the server, right? You are here, you send a message to the server, but what the server will do, it will not create a single path to everyone, right? In turn, what happens, there is a common number where you send the message and server, see here, this is what is known as a well-known FIFO. Now what happens, you write to this FIFO, your friend also writes to this FIFO. So maybe you have placed the first order, he'll place the second order. So what does the server do now? It will not create a common channel for you to write it separately. In turn, there is a well-known FIFO to which a client, all clients always writes it. So client writes to this well-known FIFO. Now from where the server will read? Server will not read from a common FIFO of the client, but will read from a well-known FIFO where everybody dumps a message. See, for example, 98450 is the customer care number of Airtel. Okay, so what I'll do, I'll send a message to that number. Problem with this, some other friend of mine also will send a message to the same number. Since the number is same, what does the server do? It will read from that same repository. Now here same repository but the well-known people. So you write a request to the server. You will not write directly to the server. You will write through a media. Now that media here is the well-known FIFO. And what does the client server do now? It will read from this well-known FIFO. So I had a problem that data is being exhausted very soon. This has a problem, call is not being connected. So I write my request here. This also writes the request here. So what is the task of a server now? To read from this well-known FIFO. But how it reads? First come, first serve basis. First in, first out, because it's a FIFO. So this has written first, so it reads this response here. So once it reads, it goes to the backend. They solve your doubts. Now they have to respond it. Now they have to respond it. But they will not respond to again this well-known FIFO. Why? Because if two people have given this error message, if both the error message are displayed to both the clients, what will you understand? Which is my request response will never understand. So what does the server do here is, whenever, see, look at now this part of the picture here. So clients always sends the request to the server through a well-known FIFO, common number 98450 98450. We know now, taking an example of item, we always send up messages to this well-known FIFO. Server reads this, processes the data. So once processing is done, now for your request, you should get the response. And are you getting this? For your request, you should get the response exclusively. So for that purpose, what does the server do is, server creates client-specific FIFOs separately. For each client, there will be a client-specific FIFO where only server writes it and you read it. Are you getting this? This is where only server writes it. See here, for example, take an example for this only now. Our WhatsApp group now, I mean to say, somebody will ask me, sir, important question of this. Somebody will ask me important questions of Unit 5. Okay, you put in the group only. Let's take practically. We'll put in the group this message. Me at this end, I'll read this messages now. The other day, people see, I posted some of the queries for me in the group also. But for me, now you have some doubt. This person also has a doubt. Now I'll not put all the answer directly in the group only. I'll put in the group again. Whose answer is what? How will you understand it? Getting this? That time, what would I have done it? I have directly texted you separately. I have texted you separately saying that, okay, for this you should do this. Somebody else, for this you should do this. This is the client server communication. See, you posted your messages in the group, WhatsApp group. So whichever is the first come first serve, I have took this message and rather than replying in the group, I have replied it separately. This is what happens with the client server communication also. Server will reply to the client separately, and for that, every server will create a client specific FIFO for writing to the client. Whereas there will be only well-known FIFO for reading it. If there are 10 clients will write only to this one well-known FIFO. But now server will create 10 client-specific FIFOs. So it will read it, process the data, and whatever is the doubt of this, it will write into this client-specific FIFO. Now what is this client's task? To read the information only from this client-specific FIFO. Similarly, this client had some doubts. It posted here. It took the information, done the processing, then it wrote. It will not knock and say, I did not call you and tell you, right? Did I call and tell you what was your doubt and all? No, I just posted in your individual WhatsApp. You see whenever you are free, right? So I hope you're getting what I mean to say here. Server will not directly call to the client because client may be active, may not be active, right? So in that case, what does server do? It will write to the client specific FIFO. It will write and keep it. Whenever the client is active, it will read from the client specific FIFO only. Now this client 1 got its information from this FIFO. This client got information from this FIFO. This is how FIFOs are used for client server communication. I hope you got this. Client server FIFO communication. Everybody? I hope you got this. Usually it is asked for 10 marks. So both the diagrams you can draw and you can explain it. Whatever I explain, that also if you can understand, you can write in your own words. Okay. One more thing, students, please be loyal again. As I said, I am having the proof, but one thing I can trust you. This is the first link. I will just post it for you there. This is for the attendance on 30th. Whoever in the group right now for me, this is for my record purpose. If you have attended, say yes. If not, say no for this. This was for 30th, which is the link I have posted first. And the link which I am posting now is for today's session. Okay. This is all the 22 people who are there in the classroom. You can give the attendance for the session 2. And session 1 is only for the people who have attended on 30th. Please make a note of it. Okay. So I'll stop for the day. We can meet on Monday. Okay. Any doubts anybody has? I'll stop recording.